Hello students, welcome back to my channel NJ Math World. Today I am going to start with the topic of engineering mathematics VTU syllabus first semester BE syllabus. Course code is 21 Math 11. It contains calculus and differential equations. Totally we have 5 modules in which first and second module is based on calculus, third, fourth and fifth is on differential equations. So we'll be learning 5 modules in the first semester. So one by one I'll be explaining you the modules in my video. So here moving on with the module 1. In module 1 we have a polar curve. So what is a polar curve? What are the topics which are going to cover in module 1? So here we'll be covering polar curve. Under that we have will be finding angle between radius vector and the tangent, angle between two curves, pedal equations, curvature and radius of curvature. In the curvature and radius of curvature we have different forms, that is Cartesian form, parametric form, polar form, pedal form, and then we'll be solving problem based on all the topics which we have discussed. So yeah, the first topic is polar curve. Now what is meant by polar curve? Polar curve are graphs of equations expressed in polar coordinates. So here if you take x and y plane, x and y plane, and there is a point placed in a space where it is called r comma theta. So this will be the radius vector. So this will be radius vector, and here this will be the angle theta, and this will be the pole. So yeah, polar coordinates where each point on the curve is determined by the distance from the fixed point. So this is the fixed point, the origin and the angle from the fixed direction. So angle is from the fixed direction, and which will be in the positive x-axis. Now where are the application of this polar curve? We see them the applications in physics, engineering, computer graphics, to describe the phenomena with a radial symmetry and the periodic patterns such as waveform, orbits, antenna, radiation patterns. So these are the some applications of polar curve. Then you have area of the polar curve. It is given as area equals 1 by 2 integration from theta 1 to theta 2 r into theta whole square d theta. And slope of the polar curve is given as dy by dx r dash of theta sin theta plus r theta cos theta divided by r dash of theta cos theta minus r theta sin theta. And some of the common polar curves which we'll be discussing in this topic is circle, where we have r equals a constant, a line theta equals alpha, then lemmacorn r is equals to a plus b cos theta or r is equals to a plus b sin theta. Cardioid is r is equals to a into 1 plus cos theta or r is equals to a 1 plus sin theta, which will be in the shape of heart. The diagram will be in the shape of heart. Then it is a rose curve, that will be r is equals to a cos k theta or r is equals to a sin k theta, where k is an integer. Then lemniscate, that lemniscate, it will be r square is equals to a square cos 2 theta and r square is equals to a square sin 2 theta. Spiral of Archimedes will be r is equals to a theta. So moving with the next one, we have polar curve can be represented. Polar curves are represented in different way. It can be represented in different ways. They are Cartesian coordinate system. First is called Cartesian coordinate system, where we have origin O, x-axis and y-axis, and the point is placed here, and this is called as plane. So here if I take it as, we can write it as x6 0 x6 o y6 will be the plane in the 2D dimensional geometry. So if you have three dimensional geometry, we'll have x, y and z axis. It will be x, y and z axis. So this will be called as three dimensional geometric diagram, 3D. So yeah, for example, you can take the house room in one corner of your room, which will be in x-axis, y and z-axis will be there. If you see the corner of your room or classroom or in your room, where we'll be having all three coordinates, that is x, y, and z, will be placed in the corner side. So yeah, then you have what is a Cartesian coordinate system. It is a coordinate system of two-dimensional geometry or three-dimensional geometry of a plane or a space. It basically is nothing but x y plane, x and y plane. So here it can be written as y is equals to f of x is equals to f of y. Now this y and x are called as dependent variable, and x and y in the right hand side is called as independent variable. So yeah, the independent variable is one which you can change, and dependent variable will change due to independent variable. So dependent variable depends on the independent variable. So all right hand variables are called as dependent, and left hand variables are called as independent variable. So next one is a parametric system. A parametric coordinate refer to the system where the position of the point is determined by one or more parametrics. So here, for example, if you take t as father and x and y as son and daughter, so son x and y depends on t. So here x and y is dependent variable and f t is independent variable, where both the dependent variable depends on the same variable t. So that will be parametrics. Okay. Rather than the directly by Cartesian coordinate x comma y and x comma y comma z, this method is offered to use the describe curves, surface and geometric shapes in the more flexible and flexible way. That is, x is equals to f theta and y is equals to f theta, where x and y depends on the theta function t. Then polar coordinate system. Polar coordinates are represented as r comma theta, where r is the radius distance or radius of curvature from the origin, and theta is the angle. So x is equals to r cos theta, y is equals to r sin theta. Why these systems are being used? So the problems which we cannot solve mathematically, we'll go with the graphical method. And here, if the problem is not solved by Cartesian coordinate system, we will go with the parametric coordinate system. Even the problem is not solved in parametric system, we'll go for polar coordinate system. So basically, these polar curves or polar systems are used to simplify the problem, complex problem, into simple methods. So yeah, we have next one is here polar transformation. What is mean by polar transformation? Polar transformation is nothing but changing the Cartesian coordinate into parametric, or into polar form, is or vice versa, is called as a polar transformation, where r is equals to f theta and be the polar curve, with the x is equals to r cos theta and y is equals to r sin theta as a polar curve. So now let us derive the equation tan phi equals r d theta by d theta by dr. So now suppose x, there is an xy plane, xy plane, x and y plane. This is called initial point, and here suppose you have a point p x comma y. We are doing it for polar, so it will be r comma theta, and there is a tangent, there is a tangent, and there is a curve there is a polar curve. So yeah, this angle is called as phi, this angle is called as psi, this angle is called as theta, and this is called as pole from the origin. Okay, so yeah, so this will be the angle which will be formed by radius vector. R is nothing but called radius vector, and this curve is called R is equals to f theta. So R is called radius vector, and theta is called the angle between radius vector and the tangent. So phi is the angle which will be formed by the radius of curvature, tangent, and the radius vector, and psi is the angle which is formed by the tangent. So now let derivation, let the slope of the Cartesian, let the slope of the Cartesian form be tan phi equals dy by dx. Now we have, since it is the theta which is changing, we can write this as dy by d theta, dividing and multiplying by d theta, we get dy by d theta divided by dx by d theta. So now that is tan psi. Now let x is equals to r cos theta, x is equals to r cos theta. So now we have to find dx by d theta, differentiating it with respect to x theta, we get dx by d theta will be, now what will be, before we differentiate, we can substitute the value of r, that will be x is equals to r is nothing but f theta, so representing it as f theta cos theta. Now differentiating with respect to theta, differentiating with respect to theta, we get dx by d theta will be using product rule, where the product rule will be first term differentiation f dash theta cos theta as it is, plus first term as it is, differentiation of second term will be cos theta, differentiation will be sin theta. Certainly dx by d theta will be f dash of theta cos theta, and this will be plus into minus will be minus f theta sin theta, f theta sin theta. So yeah, then we will go with the value, that is next one is we have y is equals to f theta sin theta, that is y is equals to r sin theta. So now differentiating with theta, dy by d theta, first term differentiation f dash theta sin theta as it is, plus f theta as it is, differentiation of sin will be cos theta. So now we have to substitute in tan phi. So tan phi will be f dash theta sin theta plus f theta cos theta. So here we have tan phi, tan psi equals f dash theta sin theta plus f theta cos theta divided by f dx by d theta is f dash theta cos theta minus f theta sin theta. So we'll target with this, we need to make this as 1. So here it will be divide by f dash of theta cos theta. So if you divide f dash of theta cos theta, we get f dash of theta sin theta divided by f dash of theta cos theta plus f theta cos theta divided by f dash of theta cos theta divided by f dash of theta cos theta divided by f dash of theta cos theta plus f theta sin theta divided by f dash of theta cos theta. So now if you cancel the terms, we get this and this will get cancelled. So cos and cos get cancelled. This whole term get cancelled. So this will be left. So yet here we get sin by cos is tan theta. Sin by cos will be tan theta plus f theta divided by f dash of theta whole divided by 1 plus what we have f theta here sin by cos is tan, so it will be f theta divided by f dash of theta tan theta tan theta. So you can call this as equation 1. So now from equation 1 we have from here from the diagram we can say we have learnt in our previous classes where we can say the exterior angle will be equal to the sum of the two interior angles. So by using that phenomena we can write psi equals theta plus phi. Now multiplying tan both the side we get tan phi equals tan theta plus phi. So we have a formula where tan theta by phi will be written as tan theta plus tan phi divided by 1 minus tan theta tan phi tan theta tan phi. So here it is tan psi. So we will call this as equation 2. Now comparing equation 1 and 2, we can compare the equation 1 and 2. We can take in place of tan phi, we can take tan phi equals, we can take tan phi equals f theta divided by f dash of theta. So what is f theta? That will be r. Differentiation of will be dr by d theta. So taking that on the numerator, we get tan phi will be r into d theta by dr. Hence the derivation is proved. Hope you people have understood what I've explained. It's a very important derivation for your module 1. Okay, thank you for watching my channel, and thank you for subscribing. Keep tuned with my channel. I'll be doing full all the questions of module 1 and module 1 of semester 1 engineering VTU syllabus. Okay, thank you for watching, students.